In this video, I'm going to compute and sketch the position, velocity, and acceleration vectors for the vector-valued function r of t with x component negative t and y component t squared. And I'm going to do this at the points described by t equals 1 and t equals negative 2. Now, from a previous video, in vector-valued functions 1, we saw that this vector-valued function draws the line in this direction. So if you want to think of it as the path of a particle, the path follows, the particle follows the line in this direction. All right. So to get started, let's first compute. Let's see, we have r of t is negative t squared. R prime of t is negative 1. So taking the derivative of each component separately, the derivative of the x component is negative 1. The derivative of the y component, t squared, we know is 2t. And then r double prime of t, the derivative of negative 1 is 0. The derivative of 2t is 2. Now, the first derivative of the position, that's the velocity. So this is the velocity. We can write this as velocity of t. This is the velocity vector-valued function. And the second derivative of the position, that's the acceleration. So we can write this as the acceleration vector-valued function, a of t. All right, so let's start with t equals 1. And for both of these points, t equals 1 and t equals negative 2, I am going to sketch the position vector in red, the velocity vector in blue, and the acceleration vector in yellow. And this is no mistake. It's no mistake that I sketch the position vector in red and the velocity vector in blue, because as you will see, the position vector we can think of as the position vector, and the velocity vector as the direction vector for a vector parameterization of the tangent line. All right, so at t equals 1, so r of 1 is negative 1, 1. So r of 1 is negative 1, 1. So there's r, and you can see that in fact points to the point negative 1, 1. The velocity vector, v of 1, is negative 1, 2. So instead of drawing the velocity vector where its initial point is at the origin, I'm going to draw the velocity vector at 1 so that its initial point is the terminal point of the position vector. All right, so so the initial point that I'm going to use for drawing the velocity vector at 1 is that point there. And now think about what these components tell you. They tell you that they tell you that wherever your initial point is, you want to go left 1 and up 2. So that's what we're going to do. We're going to go left 1 and up 2. All right, maybe a little long there. Let's try this again. Okay, good enough. And there's our velocity vector there. Now, the acceleration at 1 is 0, 2. Notice that the acceleration is constant. It's constantly the same vector, 0, 2. So drawing that with initial point being the terminal point of the position vector as well, we get that vector there. Now, what I would like to show you is, think about the tangent line, right? The tangent line, going back to Calc 1, the tangent line at the black point there, right, is that line that just barely touches the curve, right, touches the dotted curve. And if we think of the red vector as a position vector and the velocity vector as a direction vector, then at t equals 0, we get that black dot there. And at t equals 1, we would get this dot here, right? This is because, remember, thinking of the vector sum of the blue vector and the red vector, right? We would move the blue vector from this position here, right? We would move it so that its initial point was the terminal point of the red vector. And then the vector sum in green would in fact be that vector there. This parameterizes the tangent line. All right, so now let's move on to t equals -2. All right, so r of -2 is 2, 4. V of -2 is -1, -4. And A of -2, again, acceleration. Right, remember this one's constant. It's always 0, 2. All right, so first looking at our position, r of -2, that's over 2 up 4. There's our red position vector. Now drawing the velocity vector, this one here. Again, instead of drawing the velocity vector starting at where its initial point is at the origin, I'm going to move the initial point to this black dot right there. And remember what these components tell you. They tell you to the left 1 and down 4. So to the left 1 and down 4 puts us at exactly that point there. Like so. And still the acceleration at -2 is over 0 up 2. So we'll just go up 2. And again, thinking of this red vector there as a position vector for a line, and the blue vector there, the velocity vector, thinking of it as a direction vector for the parameterization of a line. We already have one point on the line, the tangent line, right? That's exactly that point there. Another point on the line would be the vector sum of the position and velocity vector, which would give you that right there. That point right there. And now think of connecting those 2 points. You see that we have a vector parameterization of the tangent line. So the velocity vector you can think of as in the exact same direction as the tangent line. And that is what we set out to do in this video.